Welcome everyone. This is a lecture on generative music sequencing in Ableton Max for Live. It will be fairly, I should say, intensely improvised, aside of the fact that there are certain things to cover, to talk about. But in terms of demonstrating them, I will try to have a free ride with different techniques and see how far we get in making a generative beat tune. Who knows? It's a tough thing, honestly. I have some experience. It's likely to end up fairly acceptable, the generative tune that I'm about to make. But I might get stuck with some things, dislike some things, get a really easy run with certain other things. But all in all, it is not necessarily about me showing off some great skill. It is about demonstrating a lot of generative techniques. So essentially what we have in Ableton Live is the MIDI effect rack, which will be the core thing that we're using here. I'm gonna remove most of the things. Now, an empty MIDI effect rack, what it allows you to do is insert MIDI effects in series or in parallel, which is crucial. Because what we're essentially going to do is we're going to use fairly simple processes, but we are going to stack them such that they do more complex and more interesting things. So that will be one thing, and then the other thing will be manipulation of MIDI signals across tracks. So we'll come to that. First of all, let me just briefly say something about these MIDI effects. So what are they? Well, they're things that input MIDI data, and they output MIDI data. So you can build your own easily in Max for Live. I kind of assume my audience has some understanding of Ableton and some understanding of Max MSP. If that's not the case, nevertheless, it should still be informative. I won't really pause too much, I believe. So if there are complex things, you can rewind, you can pause, you can look things up. Now, it might be that I'm going to build a few effects along the way with MIDI in and MIDI out. So essentially what we're looking at then is what you could call real-time generative music. Because historically generative music was quite how should I say, quite a holistic thing. The initial imagination of technicians, composers, was to create, to have a machine compose, right? So they're programming machines to compose music, which was considered obviously an artistic endeavor. It was considered to need a certain degree of genius to compose really exciting music. So they obviously consider that they're double that genius and that they can produce an algorithm that is genius. So kind of a next level thing. And in that upheaval, in that historical moment, a lot of composers were actually trying to create machines that would spit out full compositions, or at least parts of compositions that would be considered amazing music. Now, as the time went on, we kind of start using the generative tools for creating variation more so than full compositions, and also distancing from the idea of making an autonomous machine. We kind of tend to control these machines. So in that, obviously, I'm going to essentially create variation on the sequenced MIDI score, on sequenced musical patterns, you could say. And actually, because of this, all of this, all of these processes run in real time. So as the data comes in, as the MIDI data comes in that same moment, or with a minimal latency, the MIDI data comes out. So it's a real-time process, which actually means that you can use these processes in real time as well. Obviously, I will be playing back sequences through this, but you could actually have a MIDI drum kit or a MIDI keyboard and go through these processes and create much richer musical patterns from minimal amount of input. Okay, so real-time processing. So what I have here, what you're looking at, is a set of MIDI effects. I believe about 90% of these are online on max4live.com. There might be some exceptions. There might be some that are not in the scheme. It's not very neatly updated, but it's not so much about the completeness of this scheme as it is about the perspective in terms of what is the range of MIDI effects that we can use. And worth adding already is that you can use this in Max without Ableton. So all of these should load neatly into Max MSP. So you don't need to use Ableton. The reason why I will use Ableton as a framework for this is because it actually has all the general sequencing things available, and quite I should say efficient, and just got used to Ableton since 2008. As soon as Max for Live came out, I kind of started teaching Ableton, just because the initial issues with Max MSP for most students is that you have to spend a month just to code a basic sequencer. And you will see here that a fairly complex sequencer is available in Ableton already. And what we are building here, or the stuff that we're looking at, are actually really simple processes. So we kind of have the opportunity to add in extra bits, add in interesting stuff that we can design or come up with without having to code the whole framework. Okay, so this is the set of MIDI effects. Obviously, I won't go into all of these. We'll just touch on a few of these. But I'll spend some time saying something about this grid. So they're all MIDI processing effects, and typically the larger portion of these have to do with note processing. So MIDI notes coming in and coming out. On the other side here, I have some control analysis. So these typically work with control messages, which are quasi-continuous signals. And there are a few things. I'm not really using these very often, to be honest. It is also possibly out of date in terms of how you connect the outgoing signal from any of these plugins. Because typically in Ableton you would click map in the plugin and then click a dial or anything that you want to map to this output. And this has changed recently, so I'm not sure how well they work. Maybe we will give it a try. In any case, if you're doing this in Max MSP, obviously you can just hack it to just control anything you like. So what do I have in terms of control analysis? Well, gesture following, I don't have anything. This was kind of a wishful thinking. By the way, in Max MSP, there's quite a lot of work available that is complex gesture following. It's one of those things that a lot of composers of contemporary music have engaged with. And this has to do everything with complex sensor signals and complex processing analysis that yields useful, kind of conceptually easy to understand descriptions of what the sensors are capturing. So typically from body motion data, other kind of 3D data, camera data, you could actually get to things like, okay, how many people in the room, what is the overall speed of the motion, Is it a circle? Is it a triangle? What? So typically all the interesting complex analysis of control signals comes under the gesture following. Now, for me, I'm kind of a low-level preferring person, so rather than going too complex, I typically play with simpler one-dimensional signals here. I have a few things, energy. In some previous lectures, I've covered some of these things, so you can kind of retrace that. I won't go much into this. I've talked about transfer functions in a previous video as well. I'm not sure if my mass spring model actually works, but that's one of those nice things that you can look up and kind of figure out. It's essentially a model whereby the incoming motion yields an output which corresponds to a virtual mass attached with the spring to that object that is moving. So you can kind of move it abruptly and then it would go and then rest in the middle and kind of act as an object on a spring. And I mean, I'm saying that not just to fill time here. I'm actually trying to highlight the vast amount of stuff that you can come up with and that you can do. You know, how external things like masses on spring can inspire your control signal processing. I mean, bouncing ball has been a musical thing probably forever, and very much so since Aphex Twin was playing with these things, and I believe he'd done that in Max MSP as well. Okay, so those are the control signals. Probably won't do too much control signal processing. We will focus on note processing. So what do we have in terms of note processing? Well, I have some rhythm processing in terms of changing the timing of the incoming note. Okay, so random delay, some kind of delay, note delay. I believe this one delays the note based on musical durations. This one is based on absolute time. Creating flams. That's a musical term that covers kind of two notes played at almost the same time. Drummers typically play a lot of flams, percussionists, but also other instrumentalists. It's essentially an ornament, which can be quite useful. So I've mentioned that we are mostly looking at producing variation rather than producing, you know, the ultimate musical piece with a press of a button. And in doing that, it is interesting to note that, for example, if you look at 3D modeling, they're a bit ahead of us in using generative algorithms, I would say, because for them it's a very natural thing, you know, to create a texture or create, for example, if you create trees or someone's hair, you wouldn't actually 3D model, manually 3D model every branch or every hair, but you have ways of generating these textures, these dense structures, whereas most of us, I believe, we still kind of manually edit every hi-hat sound. And slowly we are moving in that direction whereby we don't have to edit the detail. We can talk about the sequence, the hi-hat pattern in terms that actually allow us to describe it rather than specify it. And that's where this vast area of creativity opens up, because you have to come up with a great way of describing it. And then obviously it's good if you can code it, but trust me, it's much more important to have this type of creativity in terms of coming up with a description, and coding it can come later, or you can ask someone to help you. But that's really the realm that we are hopefully rushing ahead into. Okay, I have another rhythm processing thing, impulse prob. So this is typically made to work with impulse instrument in Max MSP. Oh, sorry, in Ableton. And you can kind of set probability of different hits to happen. I think I can, that's probably a nice one to start with. We'll see. I've experimented with creating a rule-based system. This is an overly complex thing, to be honest, and it's really difficult to figure it out. Rules in the sense of, if this happened, then that happens. If this doesn't happen. So there is a lot of built-in logic there, and a lot of branching, and it's not a very easy thing to understand or to debug, for that matter. I'm not even sure if this one works very well. But again, I'm just highlighting that, you know, if your musical intention, or for that matter, otherwise generative thinking, is rich enough, is specific enough, then you can typically come up with these things. And what is a simple rule-based system? I mean, if I play an open hi-hat, I'm not playing the closed hi-hat. So that's a very simple thing. But then you could say, well, actually, after each open hi-hat, I need a ghost note on the snare. And things like this can become quite interesting. And obviously, because these are all meant to be real-time systems, you can easily imagine this embellishing your drummer's playing. So you can say, well, actually, every time my drummer plays an open hi-hat, this or that might happen, trigger different things. So essentially, what I'm trying to highlight here is that the most important thing, from my perspective, is to come to the point of having a really flexible tool, not being stuck with the question, what can these techniques do, but how do I get it to do what I have in mind? And that's this next level of operating the computer. So rather than being stuck and feeling like, okay, well, I am given a complex system and it can do certain things, so let me find out what it does, to have a kind of a hacker's approach in knowing that it can do anything you imagine. And then the question is, well, whether that's feasible, how complex it is. And then normally the next question is, well, actually, can I have a very similar musical function produced with a much easier algorithm, right? So you start to be able to assess the feasibility of different solutions. And obviously different solutions would have different advantages, disadvantages, and then you measure these, weigh these, and then you typically, as a good hacker, you pick a slightly disadvantageous solution, but which you can implement really quickly. And in music, this is very handy, because typically, at least from my perspective, it's not about the concept being respected, it is about the actual music coming out of your system. So, you know, you can always cheat on big, grand concepts that you might have in mind, and find easy solutions. Okay, so that's some plugins that will process the timing of incoming notes. Here I have velocity processing, so typically stuff that will change the velocity in different ways. Brownian velocity change, which is quite useful because it's kind of gradually randomized velocity trajectory. It's not totally random, so it has a sense of musical motion if you set it right. Different velocity patterns that can be independent of the sequence, which can be quite interesting. They can phase in and out. Note spectrum is an interesting one. This one, what it does, it makes it such that based on the pitch, you change the velocity, right? So in your generative things, what you might find out is that, you know, it's all good, but I'm randomizing notes across 3 octaves, and everything in the highest octave is just too loud because of the way the VST works or whatever is making the sound. So you can actually hack it on MIDI level and make sure that, you know, higher notes are softer, or create a specific transfer. You can actually draw the spectrum in the sense that you're drawing the amplitude versus frequency of the notes. Okay, so that's velocity processing. There's this multi-pattern thing which is supposed to process the pitch and the velocity. by imposing a pattern. I'm probably not going to go into these, they get quite complex there. Pitch pattern similar to velocity pattern, so it just imposes different pitches on the incoming notes. I have a detune thing, I like to work microtonal stuff, so that helps that. Essentially uses the pitch bend message, so you can hack certain synths to become microtonal, monophonically microtonal. So that was the pattern induction on top of pitch, so velocity processing, pitch processing, and then different ways of processing the pitch. Geometrical stuff, circle walk, we might actually look at this one. It's kind of inspired by the circle of fifths, so you don't randomize based on, or you don't process the notes based on their chromatic sequence, but you put them in sequence based on the circle of fifths. And you can change the size of the circle, so you can have a circle of fourths, or I mean other size circles. Interesting one. Note mirror. So essentially a kind of a geometric thing where you say, well, actually, if I have a range of notes, I put a mirror vertically, and everything that goes above actually lands below. And then there is, I believe, a reflection factor, so it doesn't have to be symmetrical like that. So you can create a kind of funny non-linear note transfer. I have a note transfer itself, which is kind of the drawing the input notes against the output notes. I've talked about transfer functions last video as well, which I find very powerful tool. Note triangle. Ooh, what would that be? I don't quite remember. Well, something to do with incoming notes transforming their pitch based on some trigonometry, I guess. So worth adding here is that with pitch processing, it does not necessarily become pitch in your outcome, because typically if you have a drum kit, then different pitches actually play different sound sources. So pitch processing, you could, I should probably put pitch / sound source choice processing, because typically if you randomize pitch, it might as well be that you obviously are randomizing the MIDI pitch value, but the MIDI pitch value is actually playing different instruments, which is something that you can say about velocity processing as well. Obviously you have velocity sensitive instruments that play different samples based on the velocity range, so it can really become anything. Okay, so these were geometric processes, which means that they are deterministic. Okay, so each time the same output will yield the same output. With patterns, they're also deterministic, but you can easily make them, they have a kind of internal state, an internal clock. So you might actually end up playing the same pattern, same sequence into the pattern process and get a different output. Based on the internal state. So this one is deterministic but has internal state. Geometric, they don't have internal state, so each time you will get the same thing. And then random stuff comes here. So this is non-deterministic. Well, actually, deep inside it is deterministic, but it's pseudo-random. So as good as it gets, it's random. Brown note, so changing the note pitch based on Brownian motion. Dice note. This is, I believe, my implementation of pink noise using the Foss algorithm, which is kind of throwing dice on different timescales and then adding them up. So you kind of have white noise on different timescales, and it does lovely musical things. Might actually look into this one, who knows. Maybe by the time I get to the end of describing it, I'll be like, okay, just make a beat and finish. We'll see. Anyhow, this is supposed to be more inspirational than conclusive. Cumulative note. Bloody hell. What was that? I can't really... Oh yeah, this is of course, this is what they call a cumulative distribution, which is essentially a way of specifying different likelihood for different nodes. So can be useful. Markov chains, I've done some Markov chain implementation for Max for Live. Basic random node, so this is white noise. and I really wonder what my transposer did, which was special. Maybe we'll find out. So that's random. Then the recursive stuff, which is chaotic algorithms. Obviously, the random algorithms do use recursive stuff, but this is more explicit in that you can control the amount of chaos. I have a video on that as well, so look that up. Essentially, the nice thing about recursive algorithms is that you can typically control it as it transitions from a steady output into an oscillation through to chaos. So I have my logistic there, logistic map, some kind of modular recursion, even more difficult to handle basic chaotic recursion, experimental. I have a little cellular automaton implementation as well, which is also quite specific, quite difficult to hack or understand. But it's there for you. I mean, cellular automata, they really allow you to use the data in so many different ways. It doesn't really... it's not really straightforward. There is no one recipe, and this is one possible mapping of cellular automaton into pitch, MIDI pitch. Okay, 2 left. Note repeating. So I have a random repeat previous. This one actually looks at a set of previous notes and repeats one of them based on some parameters. This one just randomly repeats stuff. And then note removing. Okay, so a lot of processing actually depends on removing notes, and you will see as these things start to branch and then start to converge in terms of using MIDI effects in parallel and series, that removing is a very powerful tool, because you can always generate them in many ways and then remove them, which is an interesting set of techniques. So what do I have here? I have an interval pass. So this one removes notes based on the interval to the previous note. So you can exclude certain intervals, can be quite musical. You can kind of force your system to be more harmonic. Chance grow pass. So maybe first I discuss the rand pass, which is a simpler version of that, which essentially passes notes at random. You set the likelihood of note being passed, and then it is either stopped or not. And then the chance grow pass is a nice one, because what it does is, as it's passing notes, the chance of passing the note grows, right? Because if you just have a random passing mechanism, there is no sense of sequence, no sense of continuity, no sense of precedence being significant. And in music, precedence is hugely significant. I mean, you could argue that music is all about playing with the expectations of the listeners, building them and all the rest. So chance grow pass is slightly more musical version, because what you can achieve is that the very next note is much less likely to be let through. So you typically get a kind of a sparsing in the time domain. And if there's 2 notes that were stopped, then the third one already has a much larger chance to be passed. So the chance of passing drops as soon as a note has played, and then slowly climbs up as the further notes come in. So the more time passes, the more notes come through, the more likely they will actually pass through the plugin. They will not be removed from the stream of notes, right? So again, bear in mind that all of these are real-time processing plugins, so you can actually stick them onto a live input, a live keyboard or drum kit, or whatever you're playing, as long as it's MIDI. Okay, I have a metric pass, which is a way of specifying the likelihood of note removal based on the metric position in the bar, which can be quite useful, because you might want to do something like the first beat is always passed, and then something that comes on the beat 4 has 50% chance, so you can specify the likelihood of different notes passing depending on the metric position. Consonant pass has to do with passing consonant notes more often. It's a fairly simple model of consonants. In here it is essentially a circle of fifths. So obviously unison is the most consonant, octave is the next one, and then the fifth, fourth, and so forth. So the distance on the circle of fifths will be the measure of consonants in this one. Accent pass is a nice one for ghost note randomization. Probably gonna do something like this. Anyway, so what it does, typically useful on a snare drum, what you can do is you can sequence your accents on backbeat typically, and they will always pass, and then something that's below the threshold will or will not pass. So you can actually create a dense set of ghost notes, and they will keep varying while the accented note will always be passed. And then node gate is my little hack to make detuned synthesizers polyphonic. I load the multiple set of detuned synthesizers, and then I make sure that they get different notes. So I can kind of combine the detune and the node gate to create a polyphonic microtonal synth. Okay, so that's my little grid. And now let's have some fun. So what I'm gonna do is just play with a few things. I mean, I hope I have most of these. We'll see how it goes. So my set of Max for Live plugins should be available somewhere. Here it is. Okay, so we'll keep that open, and then I think the version 2 is version 1. That was the most comprehensive one. It's been a while, 7, 8, 9 years. But nevertheless, they're simple building blocks, and they should be useful. You will find I have a set of descriptions for these as well, but all of these are actually part of the Max for Live upload, so you can find them there. Okay, and also I will actually make a point of, you know, not using something horribly complex just for the sake of using it. So always try to find simple solutions, and that's why the first few things I want to show you will actually just use Ableton's MIDI effects, built-in MIDI effects, which are quite useful. And actually the different Max for Live built-in effects are vast as well. So you see note echo, whatever, there's quite a lot of MIDI shuffler, MIDI grand. I mean, there's just a huge amount of things. So obviously you first explore and play with the stuff that you find, and then kind of think of a problem and try to solve that. So my problem that I'm going to try to solve is make something which is akin to a tune and is somewhat generative. Just to show some of these techniques. I mean, I won't spend too much time. I thought that, you know, main thing here was to open the perspective, show you the plugins, kind of briefly introduce them, and let you get on with it. That really is the crucial thing here. Okay, so let's grab a drum kit. Start with a drum kit. Okay, start with a hi-hat. Is that a good idea? I go on about hi-hats most often because they're typically very easy to randomize and kind of stay quite kind of cool. Okay, that's a conga. That's okay. This is there's no real hi-hat here, it seems. Oh my god. Maybe I'll pick a more drum kit. Yeah, I typically want a hi-hat open and close to show you a few things. Okay, so let's sequence some hi-hats. If you know me, you know that I am very worried about music in 4/4. Let's immediately do a 7/8 here. Maybe it makes it a bit more interesting as well. Actually, I'll just keep neat, make the clip in 7/8 as well. Loop length 1. Okay. An easy one, 4 + 3, something like this. Okay, I'll fatten up the snare a bit. Okay, so I have a basic beat, so now I'm gonna start randomizing stuff around and start varying things. So first important thing is to get friendly with the MIDI effect rack, because it's a very powerful thing. One thing that I will need to do here, so my first thing will be to create an open hi-hat every now and then. Okay, so in order to do that, what I will do is, first of all, I will have to create 2 branches, distinguish between the closed hi-hats and all the rest, because the closed hi-hats I can randomize away, whereas I want to keep the rest intact. Okay, so I can do this with a MIDI effect rack. Typically what I then need is 2 branches to start with. So I'll grab an empty max MIDI effect, which just throughputs every coming note. And then I will grab a built-in MIDI effect, which is called random, which will randomize the pitch. And then in order to send certain notes to each one of these, I need to use the key mapping here. And then, I mean, I can kind of cheat. I see this is my hi-hat, so I'll make the first plugin receive everything until the hi-hat, and I'll make the second plugin receive everything above. Okay, and then here are my select buttons, so I can actually test this. So indeed this chain, the top chain, is just the kick and the snares, and this is my hi-hat. Okay, so once I've done this, I can now randomize the hi-hat. So the way this random works is that you specify a chance of the event being randomized, and then you specify the amount of choices, the amount of potential different notes coming out. So in this case, I have only one potential choice. I want the open hi-hat. And then you select the scale, which is essentially the interval that it will randomize by. Okay, so if I'm playing these, actually it's happening already because this open hi-hat is just 1 semitone above. So that's actually it already. Currently I'm opening 33% of the hi-hats. Maybe I'll do a bit less, and then let's hear it. Okay, cool. So let's try to do something about ghost notes and randomizing stuff which is different in velocity. Okay, so for this, what I can do is I can do velocity mapping. And actually, this will now work in parallel with the key mapping. I could actually put 2 MIDI effect tracks one after the other and get away from this affecting both of these. Or actually, if I want a velocity mapping to affect only a certain sound, I would have to put another MIDI effect inside that chain. And that's probably the neater thing to do. So what I'll do then is I will take the kick and the snare. Maybe I should be neat and call this kick, snare. Let's call this one hi-hat. So I'm going to take the kick snare chain, which currently has this blank MIDI effect, and I'm going to put another MIDI effect rack into there. So now everything that is kick and snare will come through here, and then I can do a velocity mapping. So I'll put this MIDI blank in here, and then I will essentially have two chains, and one of them will play soft notes. Let's say the threshold is somewhere around there, and the other one will play the loud notes. So currently, you saw me sequence this. All these notes are on 95, it seems. 4. So obviously I'll have to sequence some soft things in here. So let's do that. So what you hear is that in this drum kit, the actual velocity determines the pitch more so than it determines the actual velocity. Fine. Some ghost notes here. Actually, I'll put a range of those because we're gonna remove some of them. Okay. And now what I will do is verify. You see, so this chain is now receiving all those, and then I can process them in one way or the other. So what I want now is to remove a certain percentage of these. And actually I don't even have to use my plugins for this. What I can do is just randomize the pitch. And sorry, not this one. Randomize the pitch and randomize it such that the chosen new value plays a non-existing note. Okay, so I can take 63%, one choice, huge scale, sub, which means take it lower, and then suddenly the pitches that come out, which are randomized, will probably not play a note. Okay, that's funky and groovy already. I'm inclined to stop the video before I create stuff that is not as funky and groovy. Cool, so obviously many things you can do, be more detailed about these things. One thing I would like to show you now is some kind of structural randomization. And again, within Ableton you can do a lot of these things already, and the basic thing to do is follow actions. You might be aware of this technique. So what these allow you to do is to specify the likelihood of the next clip being triggered. Okay, so first this thing I will do, I will create a clip which is a kind of a break on this. So I'm gonna do something a bit more dense. Get a few kicks, maybe like this. Let's see. Okay, so I will count that as a break. Actually, if we're emulating, oh yeah, these are very soft now. Maybe some toms. Okay. I'm not sure about that. Maybe one tom is enough, and maybe some kind of okay, that's fine. So what I can do with follow actions now is I can specify that after 1 bar, or let's say after 3 bars, there is a certain likelihood to play this again, this very clip, and there's a certain likelihood to play the next clip, and these will be the values that determine the likelihood. So currently they're equal. I think that's fine. And then for this clip, for my break clip, so let's be neat. So this is my beat, and this is my break. So for the break clip, what I will do is I'm gonna say that immediately, so after a single bar, I'm just gonna play the previous, and no chance of repeating the break because that won't really work. So what I expect now is that every now and then I'll play one bar of the break. So it went on after 3. Okay, I can groove with that. So yeah, those are the basic techniques. I won't spend too much time going into weirdness here. So the next thing, the last thing I will do is some kind of harmony bass kind of generation. The thing is that I won't really do the melody. I mean, one of the things to note is that generative melodies can be quite tricky. To me, I mean, I've explored this to some extent. The trickiest thing seems to be that the metric position is tightly related to the melodic kind of process. And that is really something that is hard to emulate with these plugins which work either on the velocity or the rhythm or the pitch. So typically if you want a really well designed melodic generative system, you would have to come up with stuff that links these domains. So without going that far, what I will do is just create something potentially interesting. And again, I'll start with the available plugins here. So first thing is Chord, one of the things that produces multiple notes from a single one. And actually, let's try to make it completely random, or not completely random. Let's look at this circle walk, if I can find it somewhere here. Circle walk is quite nice. Transposer, maybe I can search for circle in this MIDI effects things. Okay, here is a circle walk. Because what it does, hello. Not great if I have this full screen. Circle walk. Oh God. Please. Here it is. Okay. Looks like it's a bit funny. So what does it do? Well, without the chord, let's explore this. Let's get an instrument on. Whatever. Analog synth, keys. Sure. Okay, so first of all, it will have to receive a MIDI note input. As I said, these are note processing rather than generating things. So I have one note there. I will stop these. And then each time this one note comes in, but another note comes out. Now, a good way of checking what happens is creating a new MIDI track and recording the output of that previous track. And that is MIDI from Southern Skies. Okay, so I can record that into this track. And then I can visualize what it actually does. So you see it's clearly picking from a certain set of pitches. let's look at this plugin. So we have the octave start in MIDI notes, the octave size, so you can actually create funny things here. And then we have the circle step size. So this is a circle of fifths. A fifth is 7 semitones. And then I have the step table. So if I have it right, what I have is the ability to set the likelihood of different octaves. So I can keep everything in the first octave. And then I can have the likelihoods of different steps. Okay, so I can actually keep one step. I think this is something which is a bit of a bug with the new version of Ableton. As you've seen, these plugins made some 8-9 years ago. So I can kind of keep it within a single octave, which may be useful, may not be useful. I'm trying to do something bassy here, but I'm a bit worried about this very consonant thing, so I'm gonna do something with the octave size here. Let's get 11. So what you can do here is obviously play by ear. You can try to understand the algorithm, but it's equally nice to play. So I'll speed it up just to get more notes, to get a good sense of what's going on. I'll pick another octave. Okay, let's say I'm happy with that. So what I can do then is from this fundamental note I can create a chord, which is currently a fixed thing, so I'll have a fifth on top. Let's have an 11th. Oh my god. Shouldn't be dying the CPU at this stage. Looks like it is. Maybe this is a quite intense synth. Let's see if we find something else. I wasn't really happy with that sound anyway. How about this? No. These are monophonic. It sounds like. I think analog is a monophonic thing to start with. Let's see if we get some wavetable brass. Just experimenting. Maybe if I just lower the sample rate, although maybe it will mess up the recording. Let's not do that now. Anyhow, it's not supposed to be extremely I'm not sure about these. I'm not sure that this is actually polyphonic. It's a monophonic one as well, so it won't work with chords. Although I do like the sound, maybe I'll just keep it. I mean, far from liking it, find it acceptable. Let's see what are the other things here. Electric. Okay, we'll definitely find some polyphonic stuff there. Okay, so let's say this is acceptable. Let's see what it does with this beat. Okay, so I'll keep this as a chord structure, and then what I will do is devise a bass line from that, maybe with this sound. So what I have then is reading these chords into this track. And then, well, I can come up with many things here. I need to select the monitoring to get those notes in. I mean, what I could do, let's get let's just try the random pass or something like this. Random miss. Maybe that's the old version of that, probably. It is. I'm just so puzzled why I can't please do that, but never mind, here it is. So what I can do is I can select the percentage of note ons and note offs that I'm passing here, or missing. This was the old one. So I'll just miss 50% of those notes. Okay, so now what I would like to do is have these notes definitely come at a different time. I mean, one thing I definitely want is them to be of a lower pitch. So I can use the built-in MIDI effect for this, which is called pitch, just to transpose this. Maybe 2 octaves will do. Not sure about that sound anymore, but in any case, what I'm after here is a way of delaying these notes, okay, because I don't want them to hit on the beginning of the bar together with the chord. Let's see what I have for that in MIDI effects. So I have a note delay and rand delay, and I believe the note delay will do something along those lines. Let me just make sure I'm in the right track. Okay, and then note delay. Here we go. So here I can specify the grid, which is 4th notes right now, and here I can specify the likelihood of different delay times. So I can say 2 and 3. Let's see if that works. What I will need then is an 8th note grid. So what happens here is that none of the note offs are playing. I mean, if you get into building the MIDI effects, you will understand that that's one of the biggest pains, is handling the note offs as well. There are neat ways of doing it, but typically they triple the amount of work you need to do. So what I'll do here is I'll just see what happens if I just get rid of some note offs as well. That's one technique. Another thing that I can do in order to make this stop is a built-in MIDI effect, which is note length, which will kind of impose a given length. So we'll actually leave that. Let's have a fairly short length. Okay, well, I think I'll stop there. I didn't encounter something that was horrible. So I'm quite happy with this run. Again, it's just about, experimenting with basic things and coming up with challenges that you can then tackle, either with existing things, either with building your Max plugins. It's a kind of perspective opening little video, I hope. Then, yeah, be in touch. I mean, if you have any questions, things in our online future, I guess we'll be virtually meeting more frequently. So thanks for your attention and goodbye.